So continuing with the Newton's laws, the last class we have solved some of the problems related to Newton's laws of motion, and continuing with the series of the solutions, today we are going to solve some more problems. Yesterday we have the problem which we have solved of the type like this. I am recalling yesterday's lecture, that suppose we have two blocks and connected by a rope, and we apply certain force here, say F force, say it is mass m1, m2, again. So if the force acts, if this is the string having mass, certain mass m. Now this is our system, and this external force and the force by which the rope will pull the mass m1 will act as action on the system. So if this pulls by, say, small f1, the rope pulls this block by, if you draw it, this is called free body diagram. This m1. So the resultant force on this is F minus F1. According to Newton's second law, this must produce an acceleration or change in inertia of the system. So it will be m1a. Now, since if this rope is pulling this mass must also pull the rope with some force. So suppose this is the rope. So this is our system. We have isolated this from surroundings, and suppose let m1 push the rope by, say, some force F2. Now this rope is attached with another mass. This mass will also push the rope by, say, F3. So the resultant force here, F2 minus F3, is equal to MA, and is block M. If this rope is being pulled by this mass M2, obviously the rope will pull the mass M2. So suppose this pulls by force, this applied force F4, and there is no another body here. So F4 produces an acceleration on the mass M2A. Now, according to Newton's third law, F1 must be equal to F2. Is F1, F2. And if this is F3 on the rope, and this is F2. So, according to Newton's third law, these are a pair of action and reaction. So F1 and F2 must be same. It means the force by which the mass pulls the rope, the same force, by the same force the rope will pull the mass. So F1 must be equal to F2. Similarly here, F3 must be equal to F4. So if all these F1 is equal to F2, F3 is equal to F4, if you add this cancels out, we get F is equal to M1 plus M plus M2. Now, if we assumed, well, suppose the masses of these blocks are, M1 is say 5 kilogram, M2 is 4 kilogram, and the rope is of mass 1 kilogram. And let the applied force is 80 Newton. So if you substitute the values here, the acceleration will come out to be F by M1 plus M plus M2, that is equal to 80 by 5 plus 1 plus 4, that is 8 meter per second square. So the acceleration comes out to be 8 meter per second. Now if we assume the mass of the rope to be negligible. Okay. So if the ropes are massless, it means this equation, this becomes 0. So if the rope is massless, this equation 1, equation 2, equation 3. So equation 2 will, these equations will becomes like this: f minus f1 is equal to m1a. Equation a remains 1, equation remains same. This equation 2 becomes f2 minus f3 is equal to 0, and this f4 is equal to m2a. Now if f2 is equal, if this f2 minus f3 is equal to 0 means f2 is equal to f3. Now we have already discussed that f1 f2 is equal to are equal and f3 f4 are equal. It means f1 is equal to f2 is equal to f3 is equal to f4. So this means all these forces are equal. Earlier, the force on the rope, suppose the force on the block M1 is force on M1 is M1A, and A we have found out 8, and this mass I have taken as 5. So it is M1 8 and M1 was 5, and this we have calculated 8, so it is 40 Newton. And force on the rope resultant force on the rope is small m into A. So it's small m A, and small m is the mass of the rope which we have taken as 1, and acceleration as 8. So it is 8 Newton. Now force on the block M2, this will come out to be M2A. So force on M2 will be M2 times A, and M2 is 4 and this is 8, so it is 32 Newton. Now we have seen that we have applied 80 Newton force, out of which 40 Newton is used by M1 block to change its inertia. 8 Newton is required for the rope to change its inertia, and 32 Newton is required. It means out of 80, 40 is used here, and here the remaining 40 acts F1 F2, small F1 F2 will then be equal to 40. If you want, you can calculate this F1. F1 take the right hand side, M1A, 40 minus 40, that will be 40 Newton. So F1 is here 40 Newton. Out of 40, 38 Newton is reserved for the rope. So 32 Newton is left here. So F4 is 32 Newton. 32 Newton is required to accelerate this M2. Now in this case, when the ropes are massless, it means this F1, F2, F3, F4 are equal. It means no force is required for the rope. Rope required no force for its acceleration. All it does is that it just simply transfers force from M1 to M2 without any use. That's why this this F1, F2 is equal to F3, F4. Here F1 is 40 and here F4 is 32. 8, it means 8 Newton is required for the rope to accelerate. Now if the ropes are massless, the whole force F1 will be transferred to M2. So F1 will be equal to F3 and F4, F2 are equal. So it means we can write this now, this equation. It means this equation becomes F minus, or we can draw the figure like this. Now since the ropes are massless, I have just drawn a single line. It means this is an agent which transfers from force from M1 to M2 without any loss in the force. So we let it is called as T. Where T is equal to F1 is equal to F2 is equal to F3 is equal to 4. Let it called as T. So this equation becomes F minus T. F, you take only this one. This is your system. Force acting here F and here is T. F minus T is equal to M1. And on this block, so it is F minus T. And it is T is equal to M2. So it is T is equal to M. So now we have only two masses, two bodies. So we are considering only two bodies in motion. So we have two equations. There we have three bodies in motion. Thus it requires three equations. Okay. This is the repetition of your earlier class, the previous class. We have discussed this one. Now, and just move ahead. Now instead of, suppose again starting from the two block system, M1, M2, our ropes are massless. Now if you suppose we have a pulley and these are the strings. And suppose the string is, the pulley is smooth without any friction, and the ropes are massless as it is here. Suppose we have just pulley is here, and this whole thing is then hangs down due to gravity. And suppose here we have, and this pulley is supposed to be smooth, and the ropes are massless. So the picture becomes like this: M2 and here. Now and now the external forces acting on the mass M1 and M2 are due to gravity. So the gravity pulls M2 by M2 G and this by M1 G. Now suppose if one of the mass goes accelerate down, this one goes up, or you can vice versa. This goes down, this goes up. Now so let there is a tension T, because as we have seen this, if external force here, so it will be T and T. This is massless, so that this is simply the force transfer. So that the same force will act here and the same force. because the mass of the string is 0, negligibly small, and the ropes and the pulley are smooth. So the tension here in both the cases will be the same. Had the friction at the pulley has some mass or the ropes has some mass, then the tension will be different, and that we will see in another case. But here we are supposing pulley to be smooth, ropes massless. Now we can, if you concentrate on this block M2, force M2G acts downward, T acts upward. The resultant force, suppose this is greater than T, so the resultant will be the acceleration downward. So on this case we can write M2G minus T is equal to M2 times the acceleration by which it is force. Now concentrate on this M1. If T acts, if this goes down, obviously this will go up. It means the acceleration is vertically up. It means T is greater than M1G. So in this case it will be written as T minus M1G is equal to M1. So the equation of motion for both the particles, for both the blocks are written. Now you can find the acceleration and the tension by solving these two equations. Solving, we can find the tension. We can find T and the acceleration. This you can do yourself. Okay. Now let the two blocks are hanging. One block is on the table and another one is hanging by the pulley. Suppose this is another example. This is more simpler than earlier one. Here, the force of the gravity is M1G and tension in the rope is say T. And again we assume the ropes to be massless and pulley to be smooth. So this tension T will transfer from this end to this end without any loss, because there is no force is required to change its inertia, because this is massless. So for this block M1 we can write equation of motion like this. M1G, obviously M1G minus T will be equal to M1A, and here T is here, there is no external force here, so it will be T times T is equal to M2 times. Then you can solve this equation. Solving this equation will get the tension and acceleration. Now suppose we have another block here. We can use the same, using the same type of technique. Now this is another rope. if the tension in this rope is say T1, and then this on this the tension will be different. So suppose this is T2. And again here also we are considering massless string. So the equation of motion in this case now becomes m1g minus t is equal to m1a t1 minus t2. So it will be written like this: m1g minus t1 is equal to m1a. For this block, if we consider this as our system, two forces act, T1 here, T2 here, but the block is accelerating on the right hand side, so T1 is greater than T2, so it is T1 minus T2 is equal to M2A, and for the third block, only this one force acts, that is T2 is equal to M3. Now you can solve this equation, you can find both T1 and T2 and acceleration. All you have to do is simply add. If you add this cancels out, it cancels out. You will get M1G is equal to M1 plus M2 plus M3A. And A then will be M1G divided by M1 plus M2 plus M3. Knowing A, we can substitute in any of the equations, substitute the values of here A, you will get T2. You substitute the values of A here, you will get T1. So everything T1, T2 and acceleration can be found out simply by this. Now suppose another example. Suppose one of the top blocks is on an inclined plane. Now suppose this is theta. Now M2 is on the inclined plane and M1 is hanging vertically downward. So the force of gravity here, it is M1G, and let the tension here is again T, assuming again the rope to be massless and pulley to be smooth. We assume that T here. Now the gravity acts vertically down, so it is M2G. Can resolve this M2G into two perpendicular components. So it is M2G. This is theta. This is also theta. So it will be M2G cos theta, and this will be M2G sin theta. Now the equation of motion for this can be written as M1G minus T is equal to M1A. So it is M1G minus T is equal to M1A. And for this block, T is here and M2G sin theta is opposite to T, but the block is moving vertically up. It may move up or it may go down, then this will go up. I have assumed here this to be moving down and this will be moving up. Suppose you have assumed that M1 is moving accelerating down and M2 is accelerating up. But if the actual acceleration is, if you substitute the numerical values and find out that actually this must goes down, then your assumption that this is going up, the acceleration will get, you will get negative values. It means that you have assumed this to be m1 to be accelerating down, but this, if it comes out to be negative, it means this is going up and this is going down. So here we have taken, I have taken m1g to be accelerating down. So this t is greater than, so it is t minus m2g sin theta is equal to m2a. Now you can, equation of motion for both the particles are given. You can solve this one. So simply add t cancels out. This m1g minus m2g sin theta will be equal to m1 plus m2, and a can be found out. If a can be found out, we substitute the values here, we can get the t. If by chance a comes out to a negative, it means our assumption that this going up is not correct. This is going up and this is going down. Yeah. Now, two more problems. We will do this one. Then we will. So we will do two more problems I will do today, and then for the next day we will do some more problems. So suppose there is a rope here. And the problem is that, suppose the mass of the rope is given m, and force F is applied here. We want to find the tension in the string at a given distance, suppose at distance x from the end where the force is applied. The force is applied to this end, and we want to find the tension in the string at a distance x from this end. It means we want to find tension here at distance x from this end. It means this we will consider this as our system and this portion as the surrounding. And suppose the length of the string is given L. Now the portion of the string on which we are concentrating is of length x. So this portion of the string is our system of length x. So external force here F. If this is our system, but the system is attached to the next portion, L minus x portion of the string, it means there is an action and a reaction between them. It means L minus x portion of the string is pulling this portion of the ring by, say, certain force F1. So our equation of motion will be F minus F1, mass of this portion of the string, times acceleration. So F minus F1. Let the mass of this x length of the string is, say, m1. So this will be equal to m1 times a. So the equation of motion for this portion is written. Now this portion. So this is L minus x. Now if F1 force acts in between them, it means L minus x portion of the string pulls the x portion of the string by F1. By the same force, this portion will pull this L minus x. And suppose this is F2, and according to Newton's law, F1 must be equal to F2. So F2 is equal to, suppose this is of mass, so it will be M2. Now what about M1 and M2? L is the whole length. So if L length has mass M, so X length will have mass. So M1 can be written as m by l into x, and m2 will be m by l minus x. This is the mass current length into this much length. Substitute the values here, and here F1 and F2. F1 is equal to F2 according to Newton's third law. So the action and reaction is here. F1 is F2. Now you want our question is to find the action and reaction between these. So it means I have to either to find F2 or F1. You will get the answer. So F2 is M2A. So first of all, solve this equation to find the acceleration. We just simply add it. Simply add it, then this and this cancels out because F1 is F2. I will get A as F by M1 plus M2. And M1 plus M2 means capital M. So the whole F by F. Now substitute here. Either you find F21 or F2. So if you substitute, suppose F2 is equal to M2A, M2 times A is F by, and M2 is M by L minus X, F by M. M cancels out, and answer is F. Okay. Now one more problem. Before ending, I will like to solve one more problem. And suppose we have two blocks. Kept side by side. Now if you apply force F, our aim is to find the reaction between the two blocks. So this is if this is M1 and this is the external force acting. So this block M1 is hitting this M2 by say some force. By the same force M2 will hit the. So suppose this is hitting this one by say F1. So F minus F1 is equal to M1A. If this is hitting by F2, this will hit by the same force, but it's called as F1. So it is, so F2, but according to Newton's law, these F1 and F2 must be same because these are action and reaction. This is action on this and the reaction on this. If this is F1, this is F, both must be same. So now we have let us the values of M1 and M2 are given. M1 is say 8 kilogram and M2 is say 2 kilogram and F is say 40 Newton. So the acceleration will come out to be, if you add these two equations, F1 is equal to F2 cancels out because they are same. F is equal to M1 plus M2A. That means A is given by F by M1 plus M2, which is 48 plus 2, that is equal to 4 meter per second square. Now we want to find the action and reaction between them. It means either you calculate F1 or F2. Simply put the values of acceleration here, you will get. So it is F2 is equal to m2 times A, and m2 we have taken as 2 kilogram, and this is 4, that is equal to 8 Newton. Okay. Now just change the direction of the force. In the second case, suppose this force is now acting not on F1, not on M1, but on this same force, but in opposite, acting on the not on M1 but on M2. Okay. So in this case, the equation will be like this: F minus F1 is equal to M2A, F2 is equal to M1 A will be again will be same F by M1 plus M2. F we have taken F as 40 Newton and this as 8 plus 2, that is equal to 4 meter. The acceleration remains same in both cases. Now we have to find the reaction between the two blocks. The reaction between blocks is here M2 times M1A, and M1 is 8 kilogram. So it is 8 times 4, that is 32. It means that 40 Newton was applied on the block M1. Out of 40 Newton, 32 Newton is kept for M1 to accelerate. The remaining 8 Newton, 32 Newton is kept for here, and remaining 8 Newtons is supplied for to M2 to accelerate. Now if the force is applied on this side, M2 takes out of 48 Newton for itself and 32 Newton. So the reaction force, if you apply the force here from this side, reaction between here will be more than from this side. This you can observe. This is a bigger block and the smaller block. You put your hand and apply force from the smaller block to the bigger block, you will feel more reaction on your hand instead of applying from bigger to the smaller block. So all this problem in the next class we will see that if the our pulley, we have taken examples of pulley which is fixed. We have taken the pulley which is fixed and applied the blocks here. Now if this is accelerating either upward or downward, so that will be a case of accelerating reference frame. Here the reference frame to which the pulley is attached is fixed. Now in the next class we will do the problem in which the pulley is either accelerating upward or downward. So for today's, this much is for today's lecture. Yesterday we will do that. Okay. Thanks.